AEP is used to having trees fall on distribution lines, but this time it was intentional. Engineers from AEP, EPRI, and other utilities gathered at Tappan Lake, Ohio, to measure the effects of trees falling on distribution lines. The exercise was part of full-scale testing to help EPRI with the Distribution Grid Resiliency study. Representatives from AEP's Engineering Best Practices and Distribution Standards groups, Dolan Lab, First Energy, Detroit Edison, and Duke Power attended, as well as engineers from EPRI. Line crews from New Philadelphia, Ohio, and tree crews from Asplund assisted with the test setups. The Tappan Lake line, originally built in the early 1960s, was converted to underground due to multiple outages per month for the past several years. The out-of-service line was surveyed and inspected prior to the test to determine its condition.
We're doing some real-life field tests to try to replicate the damage we see during storms, which is mainly trees falling into lines. And so we've got an old line here that's out of service. We get a chance to drop real trees into it. We're really excited about that.
We're very interested in how we can make our lines to be more resilient.
This line's about 40 to 50 years old. We do have a mix of old poles and new poles in this line. Some of the trees are in the range of 6 tons, so they're pretty hefty things to be dropping across the line.
The big advantage of these tests is that it's very much real-world type testing, and it's facilities that aren't new. These facilities weren't installed just to do a test.
So what we're trying to do in general is to figure out what is going to fail, or at least try to anticipate what's going to fail, and then find ways not only to strengthen the poles where it makes sense, but also then stage what fails first.
You know, the first test this morning was good. We saw some things break we didn't plan on. We saw other things hold together much better than we expected. So I'd say the first was a very good start.
It's much easier to fix a crossarm or an insulator or a pin or something like that than it is, especially out in this kind of terrain, to fix a pole, because obviously a much heavier thing to get into place, much longer to fix.
Recent storm activity has increased the need for storm hardening and resiliency across the industry.
We've had a tough couple years. We went through Hurricane Sandy, where we worked side by side, literally with hundreds and hundreds of AEP employees. Storms are a big part of what we do, what AEP does, and our work together is essential for the public.
We've been hit pretty hard. High winds, 70 miles per hour winds, and what we've seen in the field was mainly big branches of trees that were carried away a few feet and then landed on top of our lines.
So I think the biggest issue we've had lately was the derecho here on the east side of the system, which took out, I think, around maybe like 2.3 million customers, something like that. And it affected a swath from Indiana through Ohio to West Virginia all the way to Virginia. It cost hundreds of millions of dollars to repair that damage. So anything we can do on the design side, on the restoration side to speed things up, can help cut down on those costs and those restoration times.
The Electric Power Research Institute, or EPRI, conducts research, development, and demonstration relating to the generation, delivery, and use of electricity for the benefit of the public.
Well, we're a research organization. We do collaborative research, so we have utilities all over the country. We have over 25 utilities as part of this project, and collaborating resource and experiences on how utilities respond after major storms and various ways to try to harden the system, make it more resilient so that it's easier to put back together after trees fall on the overhead lines.
Any time that we can learn and share, we'll make certain observations. We'll share those with our counterparts in AEP. They do the same, and when we can do it in conjunction with EPRI, it meets a wider audience across the industry.
So anywhere we can shave off hours, minutes of restoration time by making the system more resilient or also storm hardened, then that'll help get our customers' lights on that much quicker and maybe avoid having their lights out to start with.